Hey guys, my name is Hari, and today's talk is about the marriage of meshes on Kubernetes. So this talk is not only about service mesh. I'm going to talk about security mesh as well as data mesh, and how we, as a cybersecurity startup, we incorporated this. Quick background about me: I've written a couple of books, one on Apache Flink, and also I've written a book on Splunk. And consistent speaker in different conferences, and I'm the director of engineering as well as the data architect in the current startup. So today's agenda is, assuming it works. Okay, I'm going to use my laptop. So today's agenda is pretty straightforward. A brief history about containerization and orchestration. I'm not going to bore you guys about what Docker and what Kubernetes is. I'm assuming that you guys already know, but I'll just lay the foundations of it, because you need to understand how it works internally. That is more important when you talk about meshes. So that's something which I'll touch on, and then the various meshes which we incorporated, how we actually use Spark on Kubernetes, the different architecture which we designed to deploy Spark on Kubernetes, and various accomplishments which we did as a team. This I just had to put this because this is 2019 survey from Gartner, and I was quite surprised and probably fascinated about this. The reason why I'm surprised is because I'm not sure what those 10% is going to do. Either they're going to go bankrupt, or I have no clue. But fascinated because 90% of the industry is moving towards containers, and probably by next year, hopefully all this 90% would be in production. So this is interesting survey. As you guys know, containers are basically a standard way to package your application code, your configuration, in a deployable model. That's what container is. Docker, just quick history, or I will not say history. I just wanted to touch on some points here because it is very important. Docker is, there are different containers. Docker Rocket is another famous container. It is very straightforward. It is just modern Linux kernel features, which is used in Docker. For example, namespace for your isolation of process, C group, for your resource limitations and whatnot. Yesterday, I'm not sure if you had a chance to attend a Facebook, I don't know whose talk was it. They told the importance of C group v2. For example, some of the configurations like memory high, memory max, those are all very important when you actually do your container environment, right? So that is very important. The other capabilities, you can just go and read about it, but these components which you see on the Linux kernel, all those capabilities, end of the day, that's what Docker is all about. And the Docker daemon basically does the process through the REST API to a Docker client. So enough of this. Let's not talk about this. This one also, you guys know it. You have a Docker registry, you do the standard things. So one thing which was here is microservices. I'm assuming that how many of you are running microservices right now? Okay, so that means that I'm not going to talk about it. So Kubernetes, again, a brief history, right? I mean, in the last 2 days, this buzz is going on, right? Spark on Kubernetes. Kubernetes is going to be the next, resource manager. It is going to change the industry and all those things, right? Again, you have to understand the fundamentals of Kubernetes, right? Why? Just don't think that, I need to run something on Docker. I need to run something on Yarn. I need to run something on Mesos. You have to understand why you should run these things on these resource manager. What are the capabilities this resource manager provides you? And then go and implement it. Just don't go wherever the industry goes. Just think where you need to run. Sometimes running in Yarn would make more sense to you, right? So I'm not sure how many of you had a chance to read the Google white paper. This is a very good paper. I'll probably post the link later. talking about a scheduler. What a scheduler is, why do we need scheduler, right? So scheduler in simple terms, it basically gives a user the resources that the user want in a good, capable way. So Yarn, I mean Yarn 1, people would have run your Hadoop jobs or your Spark jobs probably in Yarn. It's basically a monolithic scheduler. So monolithic scheduler is, it just uses only one scheduling algorithm. So if let's assume that it does not prioritize your jobs, it just runs a same scheduling algorithm irrespective of the job, and it executes the job. I would say Kubernetes, in fact, in the paper also, it would have said that Kubernetes is an extended version of monolithic scheduler. The reason why it is an extended version of monolithic scheduler is because of the concept of custom resources and custom controller. I'm assuming that you already know what a controller in Kubernetes is. So, first of all, how many of you are running in Kubernetes? Okay, so controller, right? You would have used it, right? Replica set controller, all those. So you can extend your resources and your controllers in Kubernetes for your respective workloads. So it doesn't have to follow the same scheduling algorithm the same way as monolithic scheduler is. But on the contrary, since you can extend it, it is an extended version of monolithic scheduler. A two-level scheduler, which I personally love, assuming that Kubernetes is not there. Mesos is the pioneer for your two-level scheduler. Yarn 2, I mean the future versions of the newer versions of Yarn kind of does this, but Mesos is the one which actually does it in a very good way. Again, resource allocation and task allocation, that's what the two-level is. The shared state, HashiCorp's Nomad, I'm not sure if you had a chance to play with it. That is one step ahead than the two-level. What it does is your application scheduler knows what the other application scheduler does. So it can understand the entire nomenclature of a cluster, and then your resource allocation is done in a very good way without any concurrency locks. So that's what a shared state scheduler is all about. That's a good white paper. I would highly recommend for you guys to understand what it is and why you should do it. In fact, to be honest with you, there is a GitHub project for running Spark on Nomad thing too. So think about it and then see if it is going to satisfy your use case. Since you already know what Kubernetes is, I'm not going to bore you guys with this one. It's a master-slave architecture. These are the various components in Kubernetes, which you can see. One of the things which I want to quickly talk about is the services, why you should use services, in Kubernetes. I'm sure that since you're running already on Kubernetes, you know what a service is. Stateful set is also another important component. If you want to manage a state of an application, you have to use stateful set. With stateful set, you have to, if you want to have a service, you should wrap it up with a headless service, which we are going to discuss on how we design our own architecture on Kubernetes. Okay, so mesh. So this is the purpose of this talk. So those were boring. So I just wanted to talk about mesh, right? So mesh is predominantly used in telecommunications industry, and you would have used your Google Wi-Fi or the meshes that are available. So this is the definition which I got from Wikipedia, and it's kind of solving what we need to do with respect to our microservices, right? So you would have also heard about the planes, right? A lot of guys the last 2 days, right? They would have talked about data plane, control plane, sidecar. These are the buzzwords, or you guys also might have known what it is, right? But I just wanted to go a little bit deep into it on why do we need this rather than just use it, right? So data plane is very simple, right? It's a plane or a network wherein you actually carry your packet along the network from a client to client. That's what data plane is. It's straightforward. Control plane is again a simple concept. So somebody has to do configuration, right? For your data plane. That's what control plane does. To configure your data plane, to make your data plane distributed, you actually use control plane. So those are the fundamental definitions of data and control plane. And sidecar pattern, right? Sidecar pattern, you guys might have used it a lot of times. There's also one more pattern called this sidecar control. There's one more thing called init controller. In fact, if I'll show you how Spark did it. When I dug into the Spark open source code, they have something called init controller. So you need to understand the fundamental difference between a sidecar controller versus init controller, where one should use one, and then you also need to understand the concept of daemon set and whatnot. But having said that, I'll just quickly talk about sidecar pattern. So sidecar pattern goes along with your application container. It has to stay with your application container. It will stay along with your node. And what sidecar does is it actually provides, if you want to do any external capability along with your application, let's assume that you want to monitor your logs in Prometheus, right? So you can actually use sidecar container along with your application container, and then you can install it and move along. I just wanted to quickly talk about Istio. So don't think service mesh as a mesh of services, because it is not a mesh of services. I'm assuming that you guys know the OSI layers, the layer 1 to layer 7. So service mesh is more on the proxy, layer 7, right? It actually abstracts the layer 7 in a good way. You guys would have done a lot of things in your microservices using Netflix OSS, circuit breaker, you would have used Zool, Hystrix, Eureka, all those things, right? So service mesh, what it does is it basically does all those capabilities in an easy way, and that is done through an open source project called Istio. So Istio is it is from Google, Lyft, and IBM. So all these three guys contributed to Istio, and what it does is it actually does the same concept as the data and control plane, but a data plane is done through a framework called Envoy proxy. So Envoy proxy, right? Nginx, right? You know Nginx, you know HA proxy, right? Envoy proxy is the same concept. It is a load balancer proxy, but the advantage of Envoy proxy is it is a very lightweight that is written in C++ that can be deployed as your sidecar, and then that proxy is the one which intercepts your route whenever there is a communication happening between a service to service. So let's assume that you have two services. You have your Envoy as a sidecar in those two services, and the communication happens between the Envoy proxies, and then only it actually happens along with your application container. So how did Istio do it, right? So the data plane, right? The data plane is actually done through Envoy proxy, and the control plane, actually, there are various components in Istio, right? Istio actually also does your traffic management. It also does your observability. I'll talk about what that is. You can. My recommendation is I don't want to repeat what it is there on the Istio documentation, because you can go and read on the Istio documentation. I just wanted to say how how we, right? So there's a concept called pilot. So pilot is for configuring your data plane. That is for configuring your routing between services. That's what pilot. It's a component in Istio. And then there is a component called mixer. Mixer is more for your telemetry and for your ACLs. Please go and read about this. Citadel is for your authentication between your services, right? You can actually use your certificates between two services also. So that's for Citadel. And Galley is another good tool for validation of your configuration of your Istio YAML files, if I may put that way. So these components primarily help us in identifying the capabilities of microservices service mesh, like service discovery, A/B testing, circuit breaker, rate limit. All these things can be done easily in Istio using configuration, right? So you have to create a gateway, you have to create a virtual service, and the virtual service will help routing between your actual services in Istio, and voila, you can easily make it work. The other service, the Istio is not the only service mesh that is available. If you are running everything on AWS, you can actually use AWS App Mesh. Linkerd is, in fact, Linkerd is before Istio, but it did not kick off because it was not providing all the capabilities what Istio was doing. And, oh, I misspelled HashiCorp. I'm sorry about that. So HashiCorp has two components. One is a surf and one is console. Surf is more for your service discovery, and console you use it just like your etcd. So that's what that service mesh is, right? I just wanted to cover the concepts first, and then I'll tell you how we used it. So security mesh, this is one, being a cybersecurity startup, this one is very, very, very important for us because predominantly our customers are government customers, and we cannot, make it easy for anybody to hack into our Kubernetes cluster, right? So again, I want to cover the basics of networking for containers, right? So if you know so do you guys know what container network model is? What is CNM? What is CNI? Why one would use or the other? So Docker uses CNM, and Rocket, the other container, uses CNI. In fact, these are two networking models that are available right now in the industry. I would not say, let me rephrase it. These are two networking policies which are predominantly used in the industry. There are others which I am not aware of. Kubernetes uses CNI, and Docker uses CNM. So CNM, right, you have to understand the network topology, right? There is something called network plugin and an IP address management plugin. So when a Docker container comes in, both of the plugins come together, and then IP address management, which actually assigns the IP to the Docker, first gets called, and then the network plugin gets called. And then these are all managed by your etcd, or a console. For your Docker, you need to have these components, and CNM uses this kind of model. CNI, on the contrary, it is different. It is not the case. It doesn't need any separate etcd or console to manage their IP addresses, right? So that's what the networking for containers and KH is. I just wanted to quickly check something here. I don't know why my cursor is not moving. Give me 1 second. All right, I think I got it. Okay. Is it coming? Okay. All right, cool. So this pyramid is very important for hardening your images, right? So I'm sure you guys, how does Docker work? If you download from Docker registry, do you guys know how it works? It just does the preliminary SHA-256 and just says that, boom, there you go. You actually downloaded the image from your Docker registry, and then you can use it as a container, right? Is that security? Hell no. SHA-256, just downloading from a registry, you never know what exactly is there on that image unless you run the container, unless there is some hack that is going on, right? So you have to basically take everything into consideration when you run your container or when you download your image, right? It can be simple, right? It can be your runtime of your OS host, or it can be some vulnerabilities that are running on the image in your application. So all those things you need to take into consideration when you run it. So network policy, right? So network policy is one more important thing, right? So service mesh is layer 7, as I told. But you also need to understand the infrastructure, right? So Kubernetes infrastructure is very important. So layer 3 to layer 7, somebody has to manage. If it is not managed in a proper way, people can. That's the first thing. They can easily enter through layer 3 and they can easily attack your infrastructure before even going to layer 7, right? So what Calico is, so this we have used it. I'll tell you that. So Calico is an open source network policy management framework which helps in managing the policies inside Kubernetes. So I just want to take a step back, right? You guys definitely would have used AWS, VPC, subnet, and whatnot. You need to understand how it works, right? Just doing a subnet. How does AWS actually manage the security, right? So end of the day, it actually goes and does the IP table changes and ensures that your subnet is safe enough for users not to penetrate your network, right? So Calico is similar of that kind. I will not say it is exactly the same thing, but it actually manages your network policy for your infrastructure in Kubernetes, right? So in this diagram, you can see orchestrator, right? So you can actually tell Kubernetes to manage your network of Kubernetes through Calico. There is a configuration. Go and check the Kubernetes documentation. It's very straightforward. Using Flannel. So Flannel is another virtual subnet. You can actually use Calico with Flannel, with Kubernetes, with probably 5 lines of code. You can now make Calico as your network policy manager for your Kubernetes. It's there in the Kubernetes document, right? So the way it works is, you can see the orchestrator API. Orchestrator API is basically your Kubernetes API, and Felix is one of the agent that runs. Felix is one of the agent of Calico that runs on every node, which will ensure that any IP communication that is happening through the pod, it will ensure that the proper ACLs are going through that route. So I'll tell you why Calico is very important, right? I'll step back, right? See, Docker, right? You need to again understand what are the various policies or protocols, how it works. So there are something called bridge. You guys might have used Docker, right? Bridge. There's something called overlay. There's something called host, right? You would have, if you had downloaded your Docker client on your box, you might have open a bridge network so that it can actually talk outside, right? You would have done that, right? Overlay is more of a tunneling. So you might have used VXLAN for your overlay, right? What Calico does is it actually reduces the overlay noise, and it actually does the IP to IP tunneling. That's what it does right away through BGP. BGP, that is something, if you use internet, you know what BGP is. So basically, what Calico does is Calico uses BGP to make your system work at a faster rate. So that's what Calico is, and we used it in our Kubernetes cluster to manage our network policies for various ports and for our various pods too. Okay, so you remember I told about the security, right? Hardening of your images. It is very, very important to harden your images and ensure that there are no vulnerabilities that is happening on your system, right? So I'll be brutally honest with you. We use Twistlock. AquaSec, we are evaluating. We did not even, we just, day before we got the license, we are evaluating. Twistlock, I'll talk about it. So these two, it's not open source. So these two frameworks or these two technologies, right, help us in identifying vulnerabilities on your images, right? be it threat detection, be it an IP retention, right? These are some of the things which you need to understand. You need to understand what an IP retention is. You need to understand what like how a vulnerability can exist in my image through an application, right? So what twist lock does is, I'll try to see if I can read from here. So there is something, let me see if I can I maximize it? Okay, I cannot. Okay, so if you look at twist-lock architecture, right, so there's something called intelligence stream you see on the left-hand side, right? So intelligence stream is basically populated by twist-lock by various vendors. So every vendor, right, even Java CVEs, they exist on intelligence stream. It's a SaaS thing, it exists on cloud. And on the right-hand side, you see a twist-lock console. That's what we install it on our Kubernetes cluster. And the twist-lock provides 3 different defenders. One is your host defender, one is your pod defender, one is your serverless defender. So these defenders actually help in finding the vulnerability, be it at the host level, be it at the pod level, or let's assume that you are already running everything on it's productionized. If you want to introduce, see, simple things, right? If you want to say, let's assume that I want to write my own custom policy to see if a port is open. I'm just throwing a layman example, right? You can actually do those kind of defenders as a serverless defender, and you can use twist-lock to deploy that on your Kubernetes cluster. And you can even, if it fails that policy, you can even cut that pod down so that it will not even run, right? So that's what the defenders do. And we are using twist-lock. Aquasec, and by the way, we use, since we are Atlassian, now I love Atlassian personally, so everything is through Bamboo, not through Jenkins. Nothing against Jenkins, but I like Bamboo because of the remote agent concept. So everything is, the CI/CD, we did the CI/CD through Bamboo, which is even creating your defenders accordingly. Aquasec is of the same nature because both does the same thing in managing the security of your pod, but we have not even done anything with that. I mean, the Aquasec, one good thing is they are founded by Google engineers, so we have to check it out on what they have done differently. So having said that, right, so we covered service mesh, we talked about security, right? Definitely we are using Istio. I'll pound my chest and say that for microservices. And then we are also using Calico and twist-lock, right? So yes, these are 2 things, right? And then obviously, apart from your typical microservices, right? Be it a Spring Boot or be it, you write in Scala or Python, apart from your regular microservices, we also use this plethora of big data technologies. How many of you guys know Pancake Stack, which has been there for a while? Chris Fegley, I don't know whether you guys know him or not. He's from this SFO. So Pancake Stack is like, Prometheus, Arrow, NiFi, Cassandra, again, Airflow. So it's a very good thing, which he says that, hey, you know what? Any company which is actually doing containerized big data workloads, they pretty much use Pancake Stack, knowingly or unknowingly, right? S is for Spark, T is for TensorFlow, So that's something which you knowingly or unknowingly use it. But so that's what we also ended up using. So Prometheus is for our log. Oh, by the way, Prometheus is awesome. If you guys are not using Prometheus, please use it. It is one of the best monitoring NoSQL, I would say. Grafana is for for your UI of Prometheus. MongoDB, we used it for metadata management. That's what we used MongoDB. And also we did NLPs. So one of the things which we did topic modeling is through Python's GenSim. And then, one more thing, Ceph, right? You need to understand for a big data workload, right? So Kubernetes, right? Many people are confused on, hey, what happens to my volume? Can I mount my disk to Kubernetes and whatnot, right? So we used actually Ceph. Ceph is from Red Hat. So it is an object storage as well as your file storage. So that's what. So initially we started with GlusterFS. GlusterFS, NFS, GlusterFS, right? So we actually used GlusterFS, but since it was only file storage, we wanted to actually hold things in object storage just like S3. So we went with Ceph. That's the thing which Kubernetes is mounted to. It's very straightforward. Please go and check the Kubernetes document. There's a PV. You can storage class. You can just configure that, and it should work. And all other stacks are pretty straightforward. Redis for our key management. We in fact went to the edge node for collecting some of the DNS data. We sniffed the DNS packet right from the switch, so that we could do the real-time streaming using Spark. Okay, so this is what I want to touch on, right? So we did Spark architecture in two different ways. One, first of all, Spark native was done only in 2.3, and even in 2.3 it was in beta phase. 2.4 it is a little bit mature, but still it did not satisfy our problem. So we did two different architectures. One on non-native mode. Non-native mode is again straightforward. We actually created our own Docker image of the Spark from the open source project of Spark. And we did spin our Spark standalone in Kubernetes, standalone master in Kubernetes, and then we use Zookeeper, and everything for us is message driven. So obviously Kafka is something default which anybody uses nowadays. So we actually have Zookeeper. The Zookeeper would manage Kafka as well as your Spark, and this is our straightforward. The way you do your standalone deployment of Spark, that's exactly what we did. The only difference is we did put that on Kubernetes. That's the only thing which we did here. So some of the key things which you can see on the left-hand side, which I wrote here is Helm. I mean, you guys know what Helm is. So Helm, we actually created for our Spark image which we created, and then stateful set to ensure that the state of the application is managed and maintained. And why we used stateful set is for rolling updates and whatnot. One last line I want you to understand why it will be important when we talk about meshes, right? So Mist is another open source project which will actually make your Spark functions as a service. You can deploy function as a the concept of function as a service can be done through Mist. So what Mist does is, let me see if I can. So what Mist does is, Mist is actually acting as a proxy between your Spark job and your Spark master. Mist is awesome. Mist can actually support in Kubernetes. It can also, if you're still running in yarn mode, go ahead and do Mist. I mean, right? Spark job server, Apache Livy, all these things, right? So Mist is one step above this, because what it does is we can actually deploy it as a function service. Let's assume that you want to build a model, right? You can just deploy that program through Mist in an ad hoc way, and you can serve your query through your Mist, assuming that you write your Spark client job. So we did use Kubernetes job to submit the Spark job. So this is non-native, right? Why did we use non-native? Because, I mean, you guys know Spark 3, in fact, Keynote, they already told about, right? Dynamic resource was a problem, external shuffle server was not there, and the streaming, right? For streaming, you need to do checkpointing, right? And Spark native, with the checkpointing, it was throwing a lot of errors. So we actually did split the architecture in two different ways. So for streaming mode, we actually used non-native way. On the contrary, for batch analysis, wherein the user, the SOC guy or a NOC guy comes and asks more questions, that's when we actually used the native mode. And as I said, Mist is already supported in Kubernetes. So this diagram you would have already seen in 3-4 talks, assuming that you guys are already there in the Kubernetes thing. So it actually does a driver pod, and then driver kicks off your executor pods and whatnot. I don't want to bore with this, But at the end of the day, what happens is your driver pod is created, and then your executor pods are created based on the configurations which you do it. Some of the key things which you need to understand, I don't know whether they covered in other talks, right? You need to understand, see, end of the day, right? You cannot go and just create a pod just like that, with an, I mean, yes, you can, of course, with the kubectl. All I'm trying to say is, from an application, from an operator, you cannot just like that go and create it, right? It has to have access to your kube API server. So service account is very important. So you have to understand what a service account in Kubernetes is. You have to give the right credentials. You have to create a right service account so that it can access your kube API server to create your pods. So that's something which you need to realize, and then ensure that once the service account is created, it is pretty straightforward. So there are two ways of submitting, right? The one newest way is through your operator. The traditional way, I call it as traditional because 2.3, that was the only way, is through your Spark submit. So we actually used Spark submit. We did not use the operator, which has been introduced new. But end of the day, again, this was used for our batch analysis. So again, if you look at the next slide, maybe give me 1 second. Okay, so init containers, right? So Spark code actually, so that you remember I talked about why init containers is important. Go and dig right now in Spark code. You would actually see a concept of init containers. Right? So what it does is it's like a bootstrap. So it actually ensures that, hey, you know what, is the service account ready? Can I actually create my driver pod? It actually does all those things first. Once it passes, then only the driver pod is kicked off, right? That's what the init container is. If init container something is failed, sidecar is it's different, right? Sidecar is sitting on the side. So init is first kicked off first. It will just do the preliminary checks and whatnot in Spark code. And then after it has covered that aspect, it will actually go and run your Spark application. Okay, my claim on this is my observation from the Spark code on how it is done. There are a couple of spell checks there. I realized it later. So this is based on the code of 2.4. When I was trying to understand what Spark is even trying to do, how it is even doing it. It's again, yarn, right? So the right-hand side, if you know what yarn scheduler is, that's what it does, like a Kubernetes cluster scheduler backend, you would have used yarn scheduler backend, right? So that's what the executor way of doing things is. I'll talk about it soon. But here on the left-hand side, this is how the driver actually pod is getting created. So what they use is they use open source IO Fabric 8, open source project to actually run, create your pods and associate your container with your pod. So that's what it is here. It's again, pretty straightforward here. You have a Kubernetes conf inside your Spark code. It will actually check all your basic configurations, which you can change it if you want to. And then once you do it, your pod builder is now going to it's going to create your necessary pod through your Kubernetes driver builder, and then your driver pod is kicked off. And then there is a listener part which comes into picture. Based on the job, it actually creates, based on your configurations of your executors, which is there in your Kubernetes conf, it will actually do the other necessary aspects. I'll definitely share this. This will be shared. You can actually look at this later once it is shared. So what we did in our startup is, we ensured that we have our service mesh, we have our security mesh, and we have, I would not call it as a big data mesh, at least I would call it as big data stack, because we also used service mesh inside Spark jobs through Mist. And also we did have the security between Kafka and Spark also. So this is something which we integrate all along in our application and ensure that it is fine, working fine. And obviously CI/CD process is something very important. Everything is automated. Nothing is manual in our environment. Everything is automated. So I have, I'm running out of time. So accomplishments, DevSecOps, you guys have heard about the term. Time series analytics is very important for us. We can actually play back the way ML flow guys, they told, right? We actually did that manually using Cassandra, so we were able to do a playback. And in fact, we are actually doing a forecasting using machine learning on what would happen if there is a malware attack that has happened on a given endpoint. So that's what time series analytics is all about. And we did the NLP using Solar as well as the Gensim model. And then we used Prometheus for our monitoring. So key takeaways, I don't have time. Pack it up, I don't know how many of you guys, so it's equivalent to ML flow. I think Packidum probably will retire, I don't know what they're going to do. So at least in my opinion, I wanted to integrate with Packidum, because if you saw Mate's keynote today, he was talking about version management of data science, right? Packidum is exactly that. It's exactly that. You can actually create your models, and then if you want to go back and run your own version models which you created earlier, you can actually do it. So that's something which I want to try. And my suggestion for you is, please understand what is underneath the skin of Kubernetes, underneath the skin of Docker, before even you dwell or dive into any new technologies. Because if you don't understand the network underneath it, you can proudly say that you are running microservices, but it will definitely create problems. So my personal advice is, please understand what is underneath those things before you implement your network policies. Broker-based architecture is something which is straightforward nowadays we are doing. Oh, by the way, we also use structured streaming. I forgot to tell you about that. So we also did structured streaming when we did our real-time streaming. We also were able to accomplish that to show it to the user on the UI. So that's about it from my side. I think I'm definitely out of time. If you have any questions, I'll take it, or I can take it offline since I'm done.